Hello friends, very good morning. Myself Dr. M.H. Chennaiya. In today's video, we are going to draw the section of a pentagonal pyramid which is cut by a section plane which is normal to VP and inclined to HP. And let's see what is the question in store for today's video. A pentagonal pyramid of side 30 mm and height or axis 60 millimeter resting on its base on HP is cut by a section plane, that is SP, normal to VP and parallel to one of the triangular faces and at a distance of source. Friends, basically in all the pyramids and prisms, whenever the section plane has to be parallel to a triangular face in case of pyramids, parallel to a rectangular face in case of prism, we have to place the object on HP such that that particular triangular face appears as a line in the front view. So since it is a pentagonal pyramid, I am going to place the pyramid on HP such that one of the triangular faces, for example, say OAB, which is represented as O dash, A dash, B dash, will come to either to the left side of the observer or to the right side of the observer. Friends, for the given statement, I have constructed a triangular pyramid, a pentagonal pyramid to the given dimension of height 60 and side 30, such that one of the triangular faces represented by this line, triangular face, it appears as a line in the front view, and the section plane is parallel to the triangular face. That is to say, this line is parallel to this and is at a distance of 10 millimeter. So I will show that distance 10 millimeter here. And friends, after this is being cut by this section plane, which is parallel to that, and cutting this solid both at the bottom face and also along these edges. So let us retain that part of the pyramid which is to be retained for drawing the sectional views. So friends, let us first of all transfer all these corners of the pentagon to the front view. So you have got C and E, C, D, this is E, A, B, C, D, this is E, A, B, C, D. Okay, this is D dash, this is C and E, C dash, E dash. I am going to show that portion which is retained by visible lines, dark line, and the portion above this section plane is removed. That is, from here to this piece is removed. Now friends, this figure will immediately give you the front view of the pyramid. That is asked in the question, obtain front view. Then he is asking sectional top view. To get the sectional top view, this piece has been removed and we have to see which are all the base edges and which are all the slant edges that are cut by the section plane SP, that is SS. Friends, if you observe here, the base of the solid, that is A, B, C, D, is cut here. To know where exactly it is cutting, I am going to draw a vertical line through that. So it is cutting the base edge. This is CE. So base edge AE at this point, base edge, then this BC at this point. So you have got 2 points. And the distance between these two and these two will be same. Next, it is cutting these slant edges OC, OE at this point. To obtain where exactly is cutting, so we have to draw one more line parallel through that to cut OC and OE. So OC, OE is cut here, Similarly, OC is cut here. So we have got two more points. That is OC. Yeah, 2 points we have got. Next, friends, the lost line, that is the lost slant edge, is cut at this point. That is O dash E dash. The corresponding top is OD here. Draw a vertical line through that and obtain that point. Friends, now we have got here 2 points for the base, two for the slant edge OCOE, one point for this. So totally we have got 5 points here, and whatever the points you have got are to be joined by visible line. So I am going to join this to this, then here, and finally these points. So this is how the sectional view appears. And let me section this by drawing lines at 45 degrees to the horizontal. Friends, if you mark this as 1, 2, 3, this is 1 on AE, 2 on BC. So it is on AE, this is 1 comma 2. You got here, this is point 3, point 4 and point 5. And see friends, the portion apart from this is retained portion is shown here. That is, this much of portion is retained. I am going to show all those by visible lines here. A, B, C, D, this is visible. And post this A and B are removed. O, A, B are totally removed. Friends, this figure will represent the sectional top view of the pentagonal pyramid, and we have to obtain next the sectional side view. Friends, after the section plane cuts the solid, we are going to view the solid from the left direction and obtain the corresponding sectional end view. For that, friends, we have to first of all write the left end view of the pyramid, assuming it is not cut by any section plane, and obtain all the 5 points of the base and the vertex. So friends, here you are going to have the point E double dash E. At the other end, you are going to have C double dash. Then in the center, you have got A and B. So this is A double dash and this is B double dash. Friends, very obviously, this distance will be exactly the same 30. And friends, you have got D here. You will mark it as D double dash. And this is O double dash. Now friends, you are left with transferring all these points one by one to the end view. You can start from any point you like, there is no problem at all. So let me start from this point. This is on OD, that OD is here. So I am going to write a horizontal line till it meets the line, that is slant edge OD. We have got a point. Then here OC and OE are cut here. Just shift the point to OC and OE. This is going to be on the extreme slant edges. OC and OE. Friends, then you got 2 points for the base. One is on EAE. So the AE is here. How to obtain the friends? Draw a horizontal line from here till it touches 45-degree line and you get a point here. And similarly, the point 2 is obtained on the other end at the same distance. So friends, we have got basically 5 points. So we have to join all these points by straight line. So I am going to join this by straight line. Second point, third point, this is point number 4, and this is the base of the solid. So 1, 2, 3, 4, 5. Let us mark them here. So 1 is on AE. This point is 1. Then 2 is on BC. Where is point B and C? A, this is B. BC. This is point 2. Point 3, point 4, and point 5. We have got all the 5 points. And what are the points you have joined here has to be hatched. Have to section it by lines inclined at 45 degrees to the horizontal like this with equal spacing. of approximately, what do you call, some 2 millimeters. Say, friends, portion above this is removed. So if you want to transfer, you can have this transfer. This is 4, this is 5 comma 3, and this is 1 comma 2 already have marked. And friends, here you have to just see whether E is existing or not. E is there, C is there. So I have to show this portion by visible lines, again this portion by visible lines. So this is existing. And friends, this is how we obtain the left sectional end view or SSV, sectional side view. And it is what we call the sectional top view. And finally, friends, we are left with drawing the TS of the section. Friends, TS means true shape of the section. So how to find the true shape of section, friends? To obtain the true shape of section, we need to draw a line parallel to SS at any convenient distance. Say, I am going to draw a line here parallel to that. That is to say, this line is parallel to the section plane line. So anywhere convenient to you, we can have it drawn. Now friends, we have to transfer or draw vertical lines from all these, from 4, 3, 5, 1 and 2 perpendicular to this. So friends, I am going to have a line perpendicular here, say like this, another line through this point 3 and 5, another perpendicular line. Finally, from this, I have to draw one more line. So we have drawn all these lines perpendicular to this line drawn parallel to SS. Friends, on these lines, we have to obtain 1, 2, 3, 4, 5, the distance of them, measure from XY. Suppose if I want to mark 1, 1 has to be marked on this line at a distance of this much, taken from XY. Say, I am going to have this point 1 marked here. Friends, next comes the point 2. The distance from XY to this is marked as point 2 here. Say this is point 2. Next, on this line, friends, you got 3 and 5. This is 3 and 5 is nearer to us. So we are going to have 3 and 5 on this line. And finally, friends, we have the last point, point 4, which exactly falls between these two. So this is 3, comma 4, and this point is 5. So we have to join all these points by straight lines. 3 to 4, 4 to 5, 2 to 3, then 5 to 3, then this distance. So all these are to be joined by straight lines in case of all pyramids, prisms and cubes. Friends, we have to section this by drawing lines parallel to, or sorry, at an angle of 45 degrees to the horizontal. Say we are having these lines drawn equally spaced at an angle of 45 degrees to the horizontal. Friends, this figure 1, 2, 3, 4, 5 represents the true shape, that is TS of this. So friends, basically we have completed all the requirements specified in the problem, such as the front view when inspected by a section plane at an angle that is parallel to this, and in case they ask you to find out what is the angle made by the section plane with HP, we can call that angle as theta, and that can be measured using a protractor. Next, we have the top view with the section part, and this will give you the sectional top view of the solid. So, based on this, we have got the sectional end view or left sectional end view. Finally, we have got the true shape of section, a distorted pentagon, and we have taken all these distances from the XY to the corresponding points. Friends, I hope the presentation was interesting. Please go through the complete video. It is one of the good examples on the pentagonal pyramid from the viewpoint of examination and test. If you like this video, please share this video with all your friends without fail. Have a wonderful day. And this is Dr. M.H. Annaya signing off.